All right, this is section 3.1, parallel lines and transversals, and we're starting chapter 3, which is a very vocab-heavy section. And to start off with, we're going to review some vocab words that you would have used last year, and we're going to use them again this year. And the first one is parallel lines, and parallel lines are in the same plane and they don't intersect. And then when we use parallel lines, or when we have parallel lines, you'll see down here, we use little arrows like these to show that two lines are parallel. And so then our second vocab word is perpendicular lines, and these lines do intersect, but that doesn't make them special because most lines do intersect. What makes them special is they intersect at right or 90-degree angles. And to show that two lines are perpendicular, we'll use the little right angle symbol. You'll see that down there to show that we have 90-degree angles. The next vocab word you should be familiar with are vertical angles. And vertical angles are opposite angles formed from intersecting lines. So you can see here on this example, the two blue angles are vertical, and the two red angles are vertical angles. And so vertical doesn't necessarily mean they're right above each other, but it does mean they're opposite or across from each other. And the important thing to remember about vertical angles is that they are congruent, which of course means equal measure. So vertical angles are the exact same size. Next up, we have complementary angles, and two angles are complementary if their sum is 90 degrees. So basically two angles that add to 90 degrees. We can see here in this example, angle 1 and angle 2 are both adjacent angles, which adjacent means they're next to each other. That doesn't mean anything special. But if I have two adjacent angles that form a right angle, then together we would say they add to 90 degrees, which makes them complementary angles. Complementary angles do not have to be touching in order to be complementary. I can have a 45-degree angle that's not touching another 45-degree angle, but they would be complementary. Next up is supplementary angles, and two angles are supplementary if they add to 180 degrees. And so here we have, again, two adjacent angles, but together they form a straight angle, which is 180 degrees, or a straight line. So they're going to add up to 180. And just like before, two angles, in order to be supplementary, they don't have to be touching each other. They just have to add to 180 degrees. So to review those vocab words, here's a quick little problem here. It says if two complementary angles are congruent, what is their measure? And so if they're congruent, that means they're the same size. That 90 degrees gets split two ways equally. And so algebraically, we could think, okay, if there's the first angle, the second angle is the exact same size, and together that's going to make 90 degrees. And so we can just divide 90 by 2, and we find out that each of them is 45 degrees for their measure. And that makes them congruent because they're both the same. And similarly, if we have two supplementary angles that are congruent, they're going to be the same measure, we can take 180 to divide by 2. Or algebraically, you could say that two angles together are going to add to 180. And so when you divide by 2, you find out that both of the angles would have to be, in order to be the same, they'd have to be 90 degrees. So here's where we start getting into some vocab here for this year. And so the first one here is a transversal. And a transversal is a line that intersects two or more lines. That prefix trans means to cross. And so you can see in this example, we have two parallel lines indicated by the railroad tracks. And then we have a tree that's crossed the railroad tracks. And so that tree would be acting as a transversal line. So a transversal line isn't really anything super special, but when a transversal crosses two parallel lines, like in those railroad tracks, for example, then we actually have a lot of different angle relationships that are formed. And first off, we have supplementary angles, and so that word we just went over, obviously, supplementary. The second angle relationship that we'll have several vertical angles. So we'll have supplementary angles and vertical angles, and I'm writing all these down. We're going to use them here in just a moment. And then we have three new angle relationships for this year, and the first one we've actually already used. It's corresponding. So we'll have a set of actually 4 sets of corresponding angles. We have alternate interior angles. And I'll explain what these are in just a moment. And then finally, we have alternate exterior angles. So since we already defined what supplementary and vertical angles are, let's look more at corresponding angles. And we've used that word corresponding before when we talk about congruent and similar shapes and how their corresponding angles have to be equal. And if they're similar, the corresponding side lengths are proportional. And so that word corresponding means the same exact thing here. You can see here the two red angles are facing the exact same direction. In fact, it's the exact same angle on the other line. And the two blue angles are corresponding, and the two green ones and the two purple ones are corresponding. And so corresponding angles are important, just like vertical angles, because corresponding angles are always congruent. In fact, most of the angle relationships formed are congruent angles. Now, alternate interior angles. That word alternate means they're on different sides of the transversal, and interior means they're inside the parallel lines. So the two red angles here, these two angles, are alternate interior angles. They're both obtuse. They look to be the same size. They are the same size. And the two blue angles right here are exactly the same size as well. We call them alternate interior, so they're congruent. And then alternate exterior means the exact opposite. They're on different sides of the transversal, but they're outside the parallel lines. So they're equal, or they're congruent. And then the two blue angles here that I'm highlighting are also congruent. So now I want to look at a few examples and kind of put these new vocab words to the test here. We've talked about several different angle relationships. This example says, use the figure to find the measures of angle 1 and angle 2. And so angle 1 is an acute angle that happens to be the exact same size as the 63-degree angle. So angle 1 is 63 degrees. But when I explain why, I don't want to say it's congruent to the given angle because I already know that to be true. I want to know why it's congruent. And so the vocab word that I would want to use here is I would say that they are corresponding angles. So angle 1 is the exact same angle as the 63-degree angle, just on the other line. Now, angle 2 is an obtuse angle, so there's no way that angle 2 can be equal or congruent to the 63-degree angle. And so the only type of angle relationship that's formed by these two parallel lines and a transversal, the only one that's not equal is the angle relationship that says they're supplementary. And that's because angle 2 is actually going to correspond with this angle, so I know that angle is the same as angle 2. And because the 63-degree angle sits on the same line as as angle number 2, then they're going to be supplementary, and so they'll add to 180. So if we take 180 and just subtract away the 63 degrees, we get 117. So the angle 2 has to be 117. And actually, that's true about all these obtuse angles. Every single one of these obtuse angles is 117 degrees. So all the ones here that I'm highlighting in green are all the exact same. Oops. This one here and this one here. And then all the ones that I'm highlighting in red are also all exactly the same, and those are all the 63-degree angles. So we really only have two different angle measures, 63 degrees, there's 4 63-degree angles, and there's 4 117-degree angles. This next example is going to give us a chance to use more of our vocab words here. It says, use the figure to find out or find the measure of the numbered angles. What is its relationship to the given angle? And so angle 1 is going to be 75 degrees here. And the reasoning is because angle 1 is vertical. I'm going to abbreviate that. It's vertical from the given angle. So it's right across from it, and we know that means they're the same size. But we have a word for that. It's vertical angles, means they're right across from each other. Angle 2 is the next one. Angle 2 is going to be supplementary, and I'm going to abbreviate that because it's sitting right next to the 75-degree angle, and together it forms that straight line right here. And so we can do 180 minus 75, which is 105. So angle 2 is 105 degrees. Angle 3 is also going to be 105 degrees, and its relationship to the given angle is, again, supplementary. It just adds up to 180. In fact, angle 2 and angle 3 are the same size, and angle 5 and angle 7 are the same size, and it's all because they're supplementary. So actually, 4 of the angle relationships will be supplementary. So we said angle 1 was vertical, though. And we have angle 1 right here. I'm doing it in green. And then angle 4 is this one here. And angle 4 is on the other side of this transversal. It's inside the parallel lines along with the 75-degree angle. So we're going to call this alternate interior. And so it's going to be equal or congruent with the 75-degree angle. And then angle 6, right here, angle 6 is going to be corresponding with the 75-degree angle because angle 6 actually sits in the same exact spot as where the 75-degree angle. So angle 6 is 75 degrees because it's corresponding, which I'll abbreviate CORR. All right, here in the next example, it says a store owner uses pieces of tape to paint a window advertisement. The letters are slanted at an 80-degree angle. What is the measure of angle 1? And angle 1 is kind of hard to see. It's this one right here. And so this would be my transversal. And my 2 parallel lines would be this line here and that line there. And so they're both interior angles. They're for sure on the inside of those parallel lines, but they're not alternate angles. Angle 1 and the 80-degree angle are both above the transversal. So this one's the transversal. And so they're not alternate interior because of that reason. In fact, they're just going to be supplementary because this acute angle cannot be equal to that obtuse angle right there. So I do know that they'll add to 180 degrees. I know they're supplementary, and because I know they're supplementary, 180 minus 80 means that that has to be 100 degrees. So angle 1 is equal to 100 degrees. Again, this is a very vocab-heavy section. The math isn't actually very difficult. We're just subtracting from 180. But the vocab is heavy, so there's going to be a lot of questions that stress the vocab. It says this photo shows a portion of an airport. Describe the relationships between each pair of angles. We have angle 3 and angle 6. And they're both on opposite sides of this transversal. They're on the outside of the parallel lines, which makes them alternate exterior angles, which we can abbreviate. And then the next one is angle 2 and angle 7. And so again, they're on alternate sides of the transversal, but they're inside the parallel lines. So they're going to be alternate interior angles. So we have talked about 5 different angle relationships, 5 different ways that you can describe these relationships. We've talked about supplementary. And how that's basically how we describe any of the angle relationships, any of these 8 angles that aren't equal. They're going to add to 180. So we say they're supplementary. For the ones that are the same, we can say that they're either vertical, we can say they're corresponding, we can say they're alternate interior, or we can say they're alternate exterior. But what I don't want you to say is that they're congruent. 4 of the 5, so 80% of the angle relationships already say that they're congruent. That's not what I'm looking for. When we are talking about these new vocab words, we have to actually use one of these 5 to describe the angle relationship. So do not put they're congruent. Describe why they're congruent. Is it because they're vertical? Is it because they're corresponding? Is it because they're alternate interior or alternate exterior? What makes them congruent angles? All right, so I'll end with this homework question. This is number 30. It says the figure shows the angles used to make a double bank shot in an air hockey game. And so we need to find out what x is. And in order to find out what x is, we're inevitably going to have to find out what m is. And so because this is a straight angle, I know that m plus 64 plus m has to add up to 180. Now, that does not mean they're supplementary, and the reason why is because this is 3 angles. Supplementary only refers to when 2 angles add to 180. But because they do form a straight line, I know that they add to 180, so we can say this is 2m. And when I subtract the 64 over to the other side, you get 116. And so m has to be 58 degrees. So knowing that this is 58, and that this is 58, now we can solve for x. And one of the ways we can solve is by using our new vocab words. We have, again, 2 parallel lines, which I'm highlighting purple here, crossed by a transversal. So this 58-degree angle right here is equal to this angle right here because they are alternate interior angles. And for that reason, I know they're congruent, so I know this has to be 58 degrees. And then I could do the math again, but we can actually tell 58 plus 58 plus 64 equals 180. So 58 plus 64 is going to equal 180 again. So x is going to equal 64 degrees. Now the second part is going to want us to use a little bit of common sense and kind of just studying this diagram. It says you hit the red puck at the same location. Can you still get the puck to go in the goal when x is increased by a little bit? Well, if x is going to be increased by a little bit, that means it's going to be a little bit bigger than what it is now. So maybe here, right? And so it's going to bank off and it's going to adjust. And so, yeah, if you increase x a little bit, you could still make the shot in the goal. But if you increase x by a lot, then what's going to happen is it's going to bank off, or it would actually possibly even go in, but then it wouldn't be a double bank shot anymore. And so x can only be increased by a little bit. If x is increased by a lot, then it would no longer be the double bank shot. So when we go to answer our questions down here, we can see that x it says by studying, you can see that x cannot be increased and still have the puck go in the goal. That's not true. It does not have to be exact. So that's not true. It says by studying the diagram, you can see that x can be increased by a little and still have the puck go into the goal with a double bank shot. That is true. And you can increase x by a lot and still have the puck go in the goal with a single bank shot. That would be true, but if you increased it too much, it wouldn't be a double bank shot. And so that's referring to this green line that I drew here. So you can actually well, that's kind of hard to see. But if you increase it by a lot, you can still get it to go in, but it would have to be with a single bank shot versus a double bank shot.